Okay. Hello, everyone. Just wanted to say, yeah, thanks to all the presenters from this morning so far. It's been a pretty unreal morning of great talks. So I'll do my best to follow that up. So my name's Quin Johnston. I'm a master's student at the Pacific Salmon Ecology and Conservation Lab at UBC. Um, I'm supervised by Dr. Scott Hinch, and I'm going to be telling you about my master's research that was looking at the impacts of marine recreational fishing on the post-release mortality of Coho salmon in British Columbia. Okay, so starting here with these mark-selective fisheries, there was large declines of wild Coho populations in the 1990s in BC. And this ultimately led to the widespread implementation of these mark-selective fisheries within the province. And so they're essentially just the selective harvest of hatchery-marked fish. So if we look at this picture up on the top right, you can see that Coho on the top is missing its adipose fin. And ultimately, in a mark-selective fishery, like you would have heard if you saw Martin's talk the other day, those are the fish that are able to be retained in these fisheries. And so ultimately, that means that all unmarked or wild fish must be released. But really the effectiveness of a mark-selective fishery relies on the fact that those wild fish that are being captured and released actually are surviving. And so it leads us to this ultimate question, which is, are mark-selective fisheries an effective conservation measure for the protection of wild Coho populations, like what they're implemented to do? And so that brings us into some background information and sort of what led us to start with my study. So looking at previous holding work with Coho salmon, post-release mortality estimates are sitting at around 10%, and that's what's being used by managers in escapement models. And these were developed from 24-hour-long holding studies. But more recent research has shown that it takes 3 to 10 days, oftentimes, for latent mortality effects to be observed. So clearly reaching beyond that 24-hour-long period. In addition, there's been some recent telemetry work that's come out of our lab group. And so here we had Coho that were captured using rod and reel techniques and tagged with acoustic tags, and then released offshore of Vancouver Island in that green oval there, and then tracked through towards that yellow array. And what this study found was that the mortality of released Coho was 32% or even higher in some groups to that line, so pretty short term. So again, clearly reaching far beyond that 10% that's being used by managers. And what they found in this study was that bleeding and eye injuries, so two hook-driven type injury types, fork length, and then in addition scale loss, which is a sort of landing net driven injury type, really impacted the survival of these fish when they were released. And so that leads into the objectives for my study. So the first one here is to expand on the current timescales that have been used in marine Coho holding research, so getting beyond that 24-hour-long period. The second one is to examine the impacts of net use and tandem hook setups on the short-term survival of Coho salmon. Doing this again? Okay. And then the third one was to recommend methods for anglers to reduce their impacts on released Coho salmon. So best practices for anglers. So starting here with our study site, we're located in Western Canada off the west coast of BC, and specifically on Vancouver Island here in Barkley Sound. So we would go out into the sound and capture these fish using common salmon rod and reel fishing techniques. And then these fish would be brought on board and transported back to the Bamfield Marine Sciences Center, or BMSC there, where they were held in those large red tanks for a minimum of 10 days. And one thing that's really important to note here is that our fishing grounds, as well as our holding site, is on the traditional territory of the Huet First Nation, and we're really fortunate to be able to carry out our work on their land, and as well have contributions from community members in our work. Okay, so on to the methods more particularly here. It starts with the capture and transport of fish. Like I mentioned, we're catching these fish with rod and reel techniques using downriggers and single action reels. And then they're brought on board where some sampling occurs. So this includes injury assessment of these fish, a infectious agent sample, as well as a blood sample in one of the years to sort of get a sense of what these fish are looking like when they're brought into the system. These fish are held for 10 days, and then some more biological sampling occurs. So repeating all the samples that we did to see how that might have changed. And these fish are sampled over 4 days, held for 10 days, which leads to our 14-day experiments, of which we did 5 across the 2 years of the study. So looking at our study treatments here for the first year in 2024, we were looking at the impacts of mesh landing nets. And so you can see that as soon as the fish enters into that net, it starts to really thrash around, and that's where that damage to the fins and scales happens. And so to get away from that, we developed this sling landing system. So these fish are guided into a vinyl-coated sling, and in doing that, we're minimizing that damage to the scales and fins. And then in 2025, we were looking at the use of tandem hook setups. So here on the left is the tandem hook. You can see it's just two single point hooks in sequence tied into the line. And then we just have our single hook setup there on the right. And then in addition, in 2025, we found that vinyl sling worked quite well, but we wanted to make it a little bit more user-friendly. And so we put that vinyl sling in the bottom of a net hoop and called it a ning, really creative name here. And so what you can see is when we lift that fish into the boat in that ning, it's being lifted in that vinyl material. So again, we're removing that damage to the fins and scales as much as possible. All right, so we're going to jump into some results here. So first, we're looking at our survival in relation to our net treatment. So from that first year, we have survival probability on the y-axis and then time and days on the x-axis. And as we see drop-offs in that curve, that just demonstrates a mortality at that point. And so what we see here, when the sling treatment is added in, there's some mortalities as we go along. One thing that's really important to note here, like I mentioned earlier, this is where that 24-hour-long period would have finished. So clearly most of the mortality that we're observing is beyond that point, and this is for our less damaging group. And so you see when we add in the nets now, there's even more mortality after that point. But what we find here is that though the fish that were landed with a net survived more poorly than those that were landed with a sling, this trend wasn't significant, and this was really surprising to us because we know that fin damage and scale loss that are driven by landing a fish in a mesh landing net drive decreased survival upon release in telemetry studies. But there was one confounding factor here at play, which was these line wrap injuries. And so how this occurs is when a coho is hooked on the line and being brought to the surface, they have this behavioral tendency that we don't really observe in other salmon, which is that they really rotate while they're on the line. And in doing so, the leader of the fishing line wraps around these fish. And so you can see that it can potentially tear off a large number of scales. And there's two things that are important to note here. The first one is that if a fish was landed with that vinyl sling, those fish were more likely to have a line wrap injury just because of the extra manipulation that we had to do to get the fish into there. And then in addition, if a fish had a line wrap injury, it survived more poorly throughout the hold. And so what we can see here is we tried to pool together this grouping. So we have our fish that were landed with a net, our fish that had a line wrap injury, or fish that jumped out of our onboard tank and landed on the deck of the boat. And we just included that because it's a similar amount of physical interaction with the dermal surface of the fish. And what you can see here is that if a fish didn't have a dermal interaction, it survived almost perfectly throughout the hold. So that was around 96%. Whereas if the fish did have a dermal interaction, that survival drops off quite drastically, almost to 75% there. Okay, moving on here, now we're looking at comparing the number of fins damaged between all our landing treatments. And what we can see is that if a fish was landed with a mesh landing net, it has significantly higher numbers of fins that were damaged, whereas the sling and ning performed quite similarly. And then when we look at this in terms of a survival sense, you can see that if a fish didn't have a fin damaged, it survived, again, almost perfectly throughout the hold, so similar to our dermal interaction groups. But as you add in sort of 1 to 3 and 4 to 7 fins damaged, there's quite a severe drop-off in the survival throughout the holds, where it gets down to almost 60% if a fish has 4 to 7 fins damaged. So again, this is demonstrating that any physical interaction, any netting, will ultimately decrease the survival of coho salmon upon release in a catch and release sense. Okay, moving on to our results from our second year here. So looking at the tandem hooks, we have the tandems on the right, singles on the left, and here we're looking at hook wounds. So we scored our hook wounds on a ordinal scale, 0 being no hook wound, no visible injury, 1 being sort of a moderate hook wound. You can see that there's a slight tear, and then severe, you can see there's quite a large amount of tissue and potentially eye damage being present. And what we can see is that if a fish was landed with a tandem hook, they had significantly worse hook wounds. And one thing that's really important to note here as well is that these fish were landed in our ning, so our specially designed net, and then brought on the boat, and the hooks were removed on board the boat. So in reality, in a catch and release sense, if you were to release that fish at the water line or remove that hook in the net, the hook wounds that would have occurred with a tandem hook would likely be much worse than what we observed here. In addition, we pooled this into hooking locations that, in terms of ease of difficulty, so those locations that are easy to release are like the ones that are around the exterior of the mouth, and it's easy to release that fish at the water line with a tool such as a gaff, whereas those harder to release locations are further back into the mouth, like down on the bottom there. You can see the eye of the hook way back there. And what we found was that if a fish was captured with a tandem hook, they were significantly more likely to be hooked in a location that's harder to remove at the waterline. And so with these results, we get some, okay, there we go. We get some interesting validation and context for the results from some recent telemetry studies. So one thing that we found across both studies was that scale loss is important. Increased scale loss drives higher mortality. That's similar to our dermal interaction grouping. But one thing to note from this telemetry study is they found really high mortality rates to that first receiver line, like I showed you in that figure at the start. So the best conditioned fish in this study survived at 20%, which is, again, still 10% high. That's double what's currently being used in escapement estimates. But one thing that's really important to note here is that all the fish that were included in this study were landed using a mesh net. And so now we've just demonstrated that if a fish was landed in a mesh net, it has those dermal interactions, it has those fins damaged, that's ultimately going to drive decreased survival, and thus this mortality rate might be higher than what would actually be observed had these fish been released at the waterline. And so that leads into the best practice recommendations of this work. The first one is to avoid using nets unless you will keep the fish. So it causes worse fin damage as well as scale loss. And ultimately, if a fish does not have a dermal interaction, they survived at 96% for Coho in the holding sense. And then the second one here is to not use tandem hook setups. They drive worse hooking wounds and are more likely to be hooked in locations that are harder to remove. And here, if you're ever interested in coming to BC and angling for Coho salmon or Chinook in the ocean, I'll point you to this website here that's from the Sports Fishing Institute of BC, releasethamright.ca. It has all of our best practices laid out there from our past 5 years of study into this, and it as well has methods to set up your gear to properly follow the line. So the main takeaways from the study, did I turn it off? Okay, I'll talk here. The main takeaways here from this study is that any interaction with the dermal layer of Coho salmon will reduce their survival probability. But also pairing telemetry studies with holding studies gives us interesting validation of our injury-related survival trends. So now we know that scale loss clearly is a strong trend in terms of it driving decreased survival throughout the hold. And in addition, provides context for results. So now we know that if a fish is landed with a net, that decreases their survival, and that gives us more information about those mortality rates from those telemetry studies. But we have this really great news here in terms of recreational anglers, which is that small changes to angler behavior and angler gear can greatly increase the survival upon release. So something as simple as not netting that fish before releasing it can potentially have as big of an impact as 20% on the survival of those fish that you're releasing. Thanks for listening.
Awesome talk, Quin. We've got a couple minutes for some questions. Go ahead, Mike.
Yeah, absolutely. Yeah, there's tons of things that we do to these fish that's completely different from what you would do if you were releasing it. Where yeah, netting them, putting them in recovery bags inside the tanks, taking blood. They're sitting in this tank on board the boat that's bumping along as we're going all the way back to the holding site. The main thing here is we're not really, the goal of this study isn't necessarily to derive a post-release mortality estimate that's, we have 15% of Coho die when you capture them and release them, but really we're trying to get at what we can do as anglers to improve the survival of Coho when you're releasing them, so things like not netting or using single hooks. Yeah.
What you do in 4 days with these fish.
Sorry.
And the second one was the net, is that like a rubberized, knotless net or just conventional?
Yeah, okay. So to start, yeah, we captured the fish over 4 days and then we held them for a minimum of 10 days. So that's why when you look at those survival plots, they say up to 13 days on the x-axis. We took 4 days to capture them, and then from the very last fish, they were held for 10 days. And then, so sorry, can you repeat your second question?
Well, that was just if the net is a rubberized, knotless net.
Yeah, the net is it's a knotless net. It's not rubberized, but what we found from our previous work with Coho is that rubberized nets actually worsen the level of fin damage because in a lot of cases, for a rubberized net to be useful for an angler on a boat in this context, the mesh size has to be pretty big because they're already heavier as the material is thicker and all that goes into it. And so when you net a fish, there's just more area for the fins to push through the nets. And we found in previous study that drives worse damage to the fins. Yeah. So this in terms of like nets that we've used, this was like the best net that we found in terms of minimizing damage to these fish.
Okay. I'll just go on. Or is there somebody else? Yeah. Just one last one. Do you have any indication from the anglers what kind of observed scale loss and fin damage there is?
How do you mean? Sorry. I mean, yeah, we use the normal fishing practices in this study. We assess our scale loss and our fin damage per normal fishing practices, and we've done that over the 5 years of our study, not even just with this. But the thing really is that like fin damage, anglers are netting their fish and releasing them all the time, at least prior to some of our work that's been starting to come out. And so the fin damage trend is like if a fish touches a mesh landing net, their fins are 5 fins are damaged, almost guaranteed, up to 7. It's pretty severe. Yeah.
Okay, great. We're just going to do one last question over here.
That was great, Quinn. It's nice seeing some other Canadians here. A quick question is, in terms of best practices for not using nets, how easy do you think that would be to adopt? Are there already anglers out there who are landing fish without nets, or would they need something specialized like what you guys created?
Yeah. So we have seen angler uptake of our work just from anecdotal observations on the water. We're us and the guys in the SFI who talked earlier, and we're out on the water often, and we are seeing people who are making conscious efforts to release those fish at the water line. And really, a lot of the work that we're trying to do with this as well is to teach anglers how to do that properly. And so we have lots of videos and outreach and specifically with the Sports Fishing Institute, they're going to meet up with fishing guides and other anglers to sort of teach them how to use these techniques. And then in terms of like the net that we designed, the goal here isn't really to make that a useful thing for other people. We want people to not net fish at all. So that's more of a useful thing in a scientific sense in terms of that might make it easier for us to minimize our damage to the fish when we're doing studies.
Awesome. Lots of questions, lots of interest. Thanks, Quinn. Appreciate it. Anyone that's still wanting to ask questions, please find Quinn during tea. We're going to break now, and we'll be back 15 minutes after. So.